Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, question number 9, 2015, JEE Advanced Physics Paper 1. So let us start with question number 9. Students, let us solve the next question, which is question number 9. Two identical glass rods S1 and S2. These are the glass rods S1 and S2 with refractive index mu equals to 1.5 each. Have one convex end, this is convex, and of radius of curvature, this is r equals to 10 for both, 10 centimeter. They are placed with the curved surface at a distance of separation d. You can see here this distance of separation is d. At a distance of separation d, with their axis shown by, this is the axis shown by dashed lines. When a point source of light P is placed inside a rod S1, here a point source is placed at a distance of 50 centimeter. So this is a distance which is 50 centimeter, 50 centimeter. From the curved face, the light rays emanating from it are found to be parallel to the axis. So light source will come out, whatever is the, then will form some image over here, and then it goes like that, and it becomes parallel inside. Become parallel to the axis inside S2. Inside S2 it is parallel. So the distance d, you have to find what is the distance. So first of all, the diagram is to be drawn. This is S1, and this is the axis, and this is S1, and from here at a distance of 50 centimeter, I have a point source P. The light will emanate from here, suppose in this direction, and its radius of curvature is 10 centimeters. Its radius of curvature will be somewhere here, and then this is the radius of curvature, so this will be the normal. And when light travels from the denser medium, because its refractive index is 1.5, to air, its refractive index is 1, then it will move away from the normal. So this is a normal. It should have gone straight in if this glass continues, but then away from the normal, so it will bend somewhere like that. And here the image is formed, okay, due to this one. Now if I want to find where the image is formed, suppose this is the v distance. From this point the image is formed here at a distance v. So first of all, let me find where the v is formed, or due to the first one the image is suppose v1 is formed. Then I will consider another surface over here. I will consider another surface over here, that is for S2. This is S2. Its refractive index is same as this one. 1.5 is the refractive index of this. Now this distance of separation is d. So if this is v1, then this distance would be d minus v1. let us say this is your x. So this is the distance. This will be the object for this S2. Now first we will apply that refraction formula at the curved surface. The refraction at spherical single curved surface will apply for S1 then for S2. So let us apply for S1. For S1, if I apply that formula is mu2 minus mu2 by v minus mu1 by u is mu2 minus mu1 divided by r. This is the formula I am going to use. I will apply this formula for glass rod S1, which is cylindrical, this S1. Then for this one, the ray is traveling from glass to air. So air is the second medium and this is the first medium. So our formula is to write the second medium surface here. So it is in this case it is air medium divided by the image where it is formed minus this is glass, so it is 1.5 divided by u. U is at a distance of 50 centimeter to the left of the against the ray, so it is minus 50. This is equals to 1 minus 1.5. Just putting the value at mu1 you have to take as 1.5 and mu2 here you have to take as 1. Okay, u you have to take with sign which is minus 50. R we have to consider as minus because it is lying to the left, so it's minus 10. Putting that minus 10 over here, we have to solve this. This is 1 by v plus this is 3 by 2, so it is 3 by 100, and that equals to, this is minus 0.5, that is half. This is 1 by 20. This is 1 by 20. So from here 1 by v equals to 3 by 100, which is 5 minus 3, that is 2 by 100. So it is 2 by 100, which is 1 by 50. So from here v comes out to be plus 50 centimeter. That means the image we are talking about, that I have considered B1, so I will substitute B1 here because I have taken B1. So this B1 is formed at a distance of 50 centimeter. So wherever the object is, the image is also formed at a distance of 50 centimeter. Plus means it is towards the right, so image will form towards the right of this point. 50 centimeters. If this is 50, then the distance will be d minus 50. D minus 50, and that we have taken as x. So we'll solve with x, then x will put as d minus 50, and after you get x, the d value will be 50 plus x. D is 50 plus x. So we have to find actually x and put the value x over here. Now if I see the second rod, for the second rod S2, the image formed by S1 is at a distance of x, suppose, and that goes parallel. Suppose that the ray goes parallel. On this side also you can draw a diagram like this, because the ray has to come like that and like this, so it will go like that. So it is parallel. If this is parallel, then for this case the image formed V2 will be at infinity. So V2 will be infinity. The u value here is minus x. The radius of curvature will be plus 10 because it is towards right. Radius of curvature will be somewhere here. This side is the center of curvature, say. So, using the same formula again, mu2, here the rays traveling from air to glass. So, glass medium will be refractive index will write first. So, this is 1.5 divided by V, the image where it is formed is an infinity, minus 1 divided by the object distance, which is minus x, equals to mu2 minus mu1, that is 1.5 minus 1 divided by r, which is plus 10. So now 1 by x will be, this is 0, 1 by x is this is 0.5, 1 by 20. So then x comes out to be 20. So this x is 20. Then if I substitute the value of x 20 here, then I'll get d, because our question is about d. So then 50 plus x, d equals to 50 plus x, that is 50 plus 20, it is 70 centimeters. So the correct answer for this will be option number 2, which is 70 centimeter. Okay, thank you.